All right, let's go ahead and talk about solving linear inequalities. So just as a little review of the inequality symbols, if we have just the inequality symbol without the bar under it pointing to the left, this is less than. If it's pointing to the right, it is greater than. Remember, always opens up to the larger number. So if the larger number is on the left, then the left side is greater than the right side. So let's read these from left to right. And then we have the equal to, so less than or equal to. And then finally, greater than or equal to. All right. So first we're going to go through kind of the formal definition of what a linear inequality looks like. And we're looking at a linear inequality in one variable. So just like we looked at linear equations in one variable, we're doing the same thing with linear inequalities. So these are just going to have an x or whatever the variable is we're looking at, but it's not going to have an x and a y. So the standard form here is really similar to a linear equation, except instead of an equal sign, we have one of our inequality symbols. So ax plus b is less than c. And of course, we could have a less than there. We could have greater than, less than or equal to, or greater than or equal to. But the left and the right side stays the same. And again, we're going to specify here that a, b, and c are real numbers. So we're still not working with imaginary numbers. That's not going to happen in this class. And we also have to say that a cannot equal 0. And this is the same thing with a linear equation. This is because if we had a equal to 0, this first term here wouldn't exist because a would be 0, so we wouldn't have an x, and then we would just have a statement without variables. So we have to have that x there, which means a cannot equal 0. Okay, and so one thing that's different about this one compared to the equation is that instead of having the solution as just a single number, or like the special cases we saw where it was all real numbers or no solution, we can still have those two special cases. But if it's not a special case, then the solution is a set of numbers. And then we're going to talk about this as an interval. And that's because we're going to be using something called interval notation to describe our answers, because it's not just going to be x equals 2, it might be everything greater than 2 or everything less than 2. So let's look at just a couple of examples, just what they look like. We'll solve some in a second, but we're going to see something like x plus 5 is less than 2. You can also have fractions here. So let's say we had z minus 3/4 is greater than or equal to 5. And then 2k less than 10. So it doesn't have to always have another term on the left side. It's going to be the same thing as when we solve them. We're going to get the variables on one side, numbers on the other. It's going to be exactly the same except for one little thing. And so now let's quickly define something called set builder notation. And so this is something you'll see briefly in the homework, but you don't have to use this. It's going to have you fill in part of this as part of your answer for your solutions for these inequalities. So what set builder notation is the following. So let's say that we had the following here. So we're going to have curly brackets. We're going to have an x, and that's always just going to be whatever variable you're working with. So if it were the second one up here, we'd put a z right here. This vertical bar which I'll explain what it means in a second. And then whatever we get for the solution. So x, let's say less than or equal to 2. And so this is called set builder notation. Remember, sets use curly brackets, but it's different because we don't just have a list of numbers, because it would take way too long to list out all of the numbers less than or equal to 2, because this can be any fraction or decimal. And so what this says is the following. This is how we read this. This is the set of all x such that x is less than or equal to 2. And so this is kind of the long way of going about it. For the most part in my math lab, they should just have you fill in this last part here with the x is less than or equal to 2. But most of the time, we'll be using interval notation to show our solutions because it's a little bit shorter. You don't have to write out all of this. It looks a little bit nicer. So let's go ahead and look at how to graph solutions, how to write the interval notation, and then we'll get into our first example. All right, so graphing solutions. So again, let's take the example x is less than or equal to 2. So this is saying any number that is less than 2 or equal to 2 is part of our solution set. It's going to work in whatever inequality we started with. And so what we're going to do is we're going to set up a number line, and we're always going to be graphing. If it asks us to graph, sometimes you'll go straight to interval notation. And in general, I'm going to put this number in the middle, and then I'll put 1 to the left and to the right. So we'll do 1, 2, 3. And then what we're going to do is, if it is a less than or equal to, instead of using open circles and closed circles like you might have seen before, we're going to stick to parentheses and brackets. So if it's a less than or a greater than, we're going to use parentheses. If it's less than or equal to or greater than or equal to, we're going to use brackets. And the way I remember the difference is brackets have these kind of hard lines that look like equal to's if we got rid of the vertical part here. So has the matching equal to in the less than or equal to and greater than or equal to. But one thing we have to note here is that you always use parentheses with the infinities. So positive infinity and negative infinity. This part's really important. Okay, so what we're going to do, we know that we start at 2. Because it's a less than or equal to, we want everything that is less than 2, so we're going to shade to the left. And then because it's a less than or equal to 2, we're going to put a bracket facing whichever way we shaded. And that's how we graph. And now for interval notation, even if it doesn't ask to graph, I always like to graph because it makes finding the interval notation a little bit easier. We're going to get it straight from the graph. We're going to go from the furthest left to the furthest right. We're always going to go least to greatest. Just like you read a book from left to right, we're going to read the graph from left to right. So the furthest left we go is all the way to this arrow, which means that we go all the way to negative infinity. Remember, all the way to the right would be positive infinity. And we always want to use a parenthesis here, comma, the furthest right that we go is 2, because we stop shading right here. So we're going to have 2, and we have a bracket there. So you can have this kind of mix of parentheses and brackets. You sometimes might have both the same, but you should never have 2 brackets if you have an infinity, because we can't actually equal infinity, so we always use parentheses there. And so this is our solution here. It's telling us that any number between negative infinity and 2 including 2, is a solution to this inequality. All right, so now let's go ahead and try some examples. And these first ones, we're just going to be graphing and writing the interval notation. So I would recommend pausing, trying to graph them. Once you check your graph, go ahead and write, or pause again, write the interval notation, double check that. That way you know that you're getting these, or you know that you're not getting these and you need more practice. All right, number 1. Let's go ahead and try graphing x is, well, let's go with greater than -4. So for graphing this one, set up our number line. I'll put -4 in the middle. And remember, always goes least to greatest. So -5 on the left, -3 on the right. Think parenthesis or bracket. So parenthesis or bracket depends on this middle inequality here. There's no equal to, so it's going to be a parenthesis at -4. And then we want everything greater than -4. So we're going to go ahead and shade to the right. The other kind of shortcut you can do there is shade in the direction this is pointing. So this is pointing to the right. So we want to shade to the right of -4. That only works if you have it in this order. So if the x is on the left side, the number's on the right. And we'll take a look at one of them in a second that doesn't have that order, but how you can switch it around to get that order. And so now we have our graph. Now, notice how I put the parenthesis at -4 going to the right. And our interval notation, we're going to have the furthest left we go is -4 with a parenthesis there, comma, the furthest right we go is all the way over to the arrow. So that's positive infinity. Always use a parenthesis. All right, let's try another one. X is less than or equal to -3/4. So again, we'll go ahead and graph first. So I'll put -3/4 in the middle. So generally you will graph and you'll have these tick marks evenly spaced out. So these are all 1 apart. What you can do, if you have a kind of ugly fraction, you don't have to have those kind of reference tick marks. If you want to, you can go by quarters. So if I went down a quarter, we're at -1. And if I went up a quarter, we'd be at -2/4, which is -1/2. All right, so now if I graph this, less than or equal to, so we're going to have a bracket, and it's a less than, we're going to the left. So bracket, shade to the left. And then our interval notation, for this left that we go, is this tick marks right here for the -1. We go all the way to -infinity. Always use a parenthesis there. Comma, the furthest right we go is -3/4 with a bracket. All right, so let's go ahead and do one last graphing example so you guys can see what this looks like. Let's do 0 is less than x. So for this one, if you notice the x is on the right side, and so you always want the x to be on the left side, because right now it looks like this is a less than and we would shade to the left. But this is saying that 0 is less than x, which if we read it backwards is saying x is greater than 0. But the way that's a little bit easier to see that is if you switch around the x and the 0, you also have to flip the inequality. So this is always the better way of writing it, with your x's on the left side. That's why when I was solving equations, I tried to always get the x's on the left, but you can always do this kind of switching around of your x and the number. All right, so now let's go ahead and put 0 in the middle, and I'll do -1 and 1. And so think parenthesis or bracket, parenthesis because it's greater than, there's no equal to, and then shade to the left or to the right, shade to the right because we want everything greater than 0. So parenthesis, going through 0, shade to the right. And then the interval notation, we want to start at 0 and then go to the furthest right, which is infinity. All right, this next set of examples, we're going to be going backwards. And what I mean by that is we're given a graph and we want to write an inequality. So write an inequality. Number 1, we're given this graph here. So we're given 3, 4, 5. And then there's a parenthesis at 4, and we're shading to the right. So when it says write an inequality, it doesn't say write the interval notation. The inequality is the part that says x is less than 3 or x is whatever we're looking at. So we want to figure out if we want a less than or a greater than. Well, we have everything greater than this number shaded. So we're going to have a greater than, and our parenthesis here is at 4. And there's no equal to symbol because we don't have a bracket, we have a parenthesis. And that's all they're looking for in that one. Let's go ahead and try one more. And since we did that first one together, I'd suggest pausing this to see if you can get it. -3, -2, -1, bracket at 2, -2, shading to the left. All right. So we're going to have x in the front. Figure out if it's a less than or greater than based on where we're shading. Well, we have everything less than -2 shaded. And since it's a bracket, we need less than or equal to, and that falls right at -2. So x is less than or equal to -2. All right. So in this next set of examples, we're told to solve the inequality. So I'm actually going to go ahead and start solving some. And graph the solution set. All right, so let's go ahead and let me check something. All right, let's go ahead and actually solve this, graph this, and write interval notation. So number 1, let's take a look at -1 plus 8r is less than 7r plus 2. So just like I did with linear equations, we still want to get the variable alone. and positive. And this one's optional because you can switch it around. But I'm going to throw in that it should be on the left side, just because it's going to make graphing it a lot easier. So let's go ahead and get the variables on the left first. So I'll subtract 7r. So we have -1. 8 minus 7 is 1, so plus r is less than, that's all staying the same, 2. And then I'll go ahead and add this 1 over to the right. So we get r is less than 3. So now if we go ahead and graph this one, I'll put 3 in the middle, 2 on the left, 4 on the right. It's a less than, so parentheses or brackets should be parentheses. And to the left or to the right of 3, we want to shade to the left because we want everything less than 3. So parentheses, shade to the left. So then our interval notation, and I'm going to label this just so you know, once again, that the interval notation is this part that we write at the end. This is the inequality. This is the graph. This is the interval notation. So let me write that just in case in the homework they specify inequality versus the graph versus the interval notation. Okay, so furthest left that we go on the graph is -infinity, always a parenthesis. Furthest right we go is 3 with a parenthesis. All right, let's go ahead and try another of those. Five plus 5x. Actually, let's go ahead and look first at where inequalities and equations differ. So then we can jump into the rest of these examples here. So inequalities and equations differ, besides the fact that the answer isn't just a single number for inequalities. There is one difference when we're solving them. So in the one we just saw, there was no difference at all, except for really wanting to get the variable on the left. There is a difference when multiplying and dividing by a negative. So if we go ahead and take a look at why that is, let's say that we have 2 is less than or equal to 4. Actually, let's go ahead and just look at 2 is less than 4. If we had an equality statement, you don't need to write this part down, but if we had 4 equals 4, and then I multiplied both sides by a -5, the left side is -20, the right side is -20, it's still equal, we don't have a problem. So let's look at this inequality here. So 2 is less than 4, that's true. If I multiply each side by 2, then we get 4 is less than 8, still true. But if I go ahead and start with the same statement and multiply both sides by -2, -2 times 2 is -4. 4 times -2 is -8. And -4 is not less than -8. It's further to the right on the number line, so it's bigger. So in order to make this true, we have to flip the inequality. and that's whenever we multiply or divide by a negative. It doesn't matter if the starting number is positive or negative, it just matters what we're multiplying and dividing by. So when multiplying or dividing by a negative. All right, so now let's look at some more examples. So we want to solve, graph, and write the interval notation. Number 1, 9x is less than negative 18. So solving this one, we already have all the variable terms on the left, constants on the right. So we want to go ahead and divide by 9. So left side cancels, we get x. We didn't divide by a negative, even though there's negative up here, that's perfectly fine. So we don't need to flip. Negative 18 over 9 is negative 2. All of those sign rules still apply. And let's go ahead and graph this. So I'll put negative 2 in the middle, negative 3 on the left, negative 1 on the right. Try to figure out if it's parenthesis or bracket, and then which direction we're going to shade. So if it's a less than, we're going to have a parenthesis, and we want everything less than negative 2. So we're going to go to the left, parenthesis, shade to the left. And then our interval notation, the furthest left we go is negative infinity, always parenthesis there, comma, the furthest right we go is negative 2 with another parenthesis. All right, let's try another one. Negative 2r is greater than negative 12. So again, no simplifying to do right now, and all of our variable terms are on the left, constants on the right. So we can go ahead and divide both sides by negative 2. Now, since we're dividing by a negative, we have to flip the inequality. I like to do that first just so I don't forget it, because it does happen. And now we can start dividing. So these negative 2's cancel. We're left with r. Negative 12 over negative 2 is positive 6. So r is less than 6. Set up our graph. So we have 6 in the middle, 5, 7 on the right. And so we want everything less than 6, so less than parenthesis, and less than pointing to the left. So parenthesis, shade to the left. And our interval notation, the furthest left we go is negative infinity, parenthesis there. Furthest right we go is 6 with another parenthesis. All right, let's go ahead and try one that has a little bit more work to it. Negative 15 minus parenthesis 2x plus 1 is greater than or equal to 4 parenthesis x plus 1 minus 3x. So this one straight away, it's a little bit longer than the ones we just looked at. But just like solving equations, we're going to go through and simplify first. So let's go ahead and distribute. So leave negative 15. We're distributing a negative 1. So negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. Greater than or equal to 4 times x is 4x. 4 times 1 is 4, so plus 4. Minus 3x. Now let's combine like terms. So negative 15 minus 1 is negative 16 minus 2x is greater than or equal to 4x minus 3x is x plus 4. Everything is simplified, so let's get the variable terms on the left. So let's subtract x. Now we have negative 16. Negative 2 minus 1 is negative 3x. Greater than or equal to, so we subtracted x, but we didn't divide by a negative, so we don't need to flip it quite yet. 4 on the right. Now let's add 16 to both sides. Again, we're just adding. Adding and subtracting is completely fine, so we don't need to flip. We get negative 3x is greater than or equal to 20. And now, if we divide both sides by negative 3, we're dividing by a negative, so we're going to have to flip to a less than or equal to. The left side becomes x, and the right side is 20 and a third, and 20 and a third is usually perfectly fine. You can still write it here, but when you go to graph it, it's easier to see what number it is if we change it to a mixed number. So 3 goes into 20 6 times with a remainder of 2, so 6 2/3. And then our graph here, I'll put 6 2/3 in the middle. And for this one, I'm not going to put any numbers on the outside. If you wanted to go up and do 7 2/3, here I'll actually add these in, and 5 2/3 below it. That way you're just going up and down by 1. That's fine. And now less than or equal to means bracket. Less than, go to the left. So bracket, shade to the left. And then our interval notation for this left, negative infinity. For this right is 6 2/3, or you could put 20/3 there, but make sure it has a bracket. All right. Let's go ahead and take one look at, what number is that, 3? Okay. I'll look at one more of these before we see some word problems. So for this next one, just so we can see some fractions, 1/8 times x plus 4 is greater than or equal to 1/6 times 2x plus 8. So that we don't have to work with fractions here, let's go ahead and get rid of them. But before we can do that, we have to distribute. So 1/8 times x is 1/8 x. 1/8 times 4, or 4 over 1, is going to be 4/8, which is 1/2. So I'll go a little bit faster through the fraction multiplication and addition now. Greater than or equal to 1/6 times 2x. 1/6 times 2 over 1 is 2 over 6, which is 1/3. So we have 1/3 x plus 1/6 times 8. Oh, I'll do it down here. 1/6 times 8 over 1 is 8 over 6, which is 4/3. So now we want to go ahead and multiply everything by the LCD. So our LCD here for all 4 of these, 3 goes into 6, but 8 does not. So let's look at the multiples of the largest number, which is 8. So 8, 3 doesn't go into it. 16, 3 doesn't go into it. 24, 3 and 2 and 8 go into it. So it's going to be 24. And the trick with that one, if you're finding the LCD, is always look at the multiples of the largest number. That way you'll have less to check. Now let's go ahead and multiply all of these by 24 over 1. Remember every single term. And now I'll reduce, so 8 and 24 reduces to 1 and 3. This should always turn your denominators into 1, so we have 3x plus 2 reduces to a 1, 24 reduces to 12, so we're just left with a 12. Greater than or equal to 3 and 24, we're going to reduce to a 1 and an 8. So now we're left with 8x. You can always do this off to the side. I didn't leave quite enough room here. And then let's reduce this last one to a 1 and an 8. And 4 times 8 is 32. Fractions are all gone, so now let's go ahead and start solving this. I'm going to move all of the x's over to the left, so minus 8x. Getting ahead of myself there. We're going to get the 5x over here. Negative 5x plus 12 is greater than or equal to 32. Get rid of this 12, so minus 12. Still haven't multiplied or divided by a negative. So we have negative 5x is greater than or equal to 20. And then divide both sides by negative 5, dividing by a negative, so flip. And we get x is less than or equal to negative 4. So negative 4 in the middle, I'll put negative 5 on the left, negative 3 on the right. And then we want a bracket, so it's less than or equal to, and it's less than, so we shade to the left. And then our interval notation, the furthest left we go is negative infinity, comma, the furthest right we go is negative 4 with a bracket there. All right, so this next set of examples here, we're going to be translating some inequalities into mathematical statements. So we're told to translate into an inequality and told to use x, so you're not using any other variable. So number 1, the cost is less than $10. So these ones is just a single inequality, and we don't know what the cost is, so that's our x, but we know it is less than $10. So x is less than 10, and that's all we're doing here. Number 2, Chicago received at most 5 inches of snow. So we know that they didn't receive, since they received at most 5 inches, that means they could have received exactly 5 or less than 5, but not more than 5 inches. So that means that how much snow they received, x, because we don't know what it is less than or equal to 5. And we're going to assume here that x can't represent negative numbers because we can't have negative amounts of snow. Number 3, the car's speed exceeded 60 miles per hour. All right, so here the keyword is exceeded. That means that we went over 60 miles an hour. It wasn't equal to it. So the car speed, which we don't know is x, exceeded had to have been greater than 60 miles per hour. So x is greater than 60. And one final one, you must be at least 18 years old to vote. So your age, which again we don't know, so we'll call it X, has to be at least, means you can be 18 or you can be older than 18. So we're going to have greater than or equal to 18. All right, so those ones aren't too bad. This next example is a little bit trickier. It's going to deal with grade averages. So let's go ahead and translate and solve this next example. Don't need a number one there. There we go. All right. So Matthew has grades of 98, 98 and 85 on his first two exams. If he wants an average of at least 92, what must he get on his third test? And so we're going to assume here that everything is equally weighted. It's not like in our class where there are a certain percentage of your grade. These are his only grades. So we don't know what he has, what he got on his third test or what he's going to get. So that'll be our variable. We want to define our variable. So let's say x is equal to the third test score. And so to find average, you add up all of your scores divided by how many items that you had. And then we're going to use that to compare it to the average that he wants. So our average, we have a 98, an 85, plus 85, plus his third test score, which is x. If we divide that all by 3, that gives us the average. And he wants the average to be at least, which means greater than or equal to 92. So the average greater than or equal to 92. And so now for solving this one, this is one that we haven't really seen before. So the first step is kind of new, but what we want to do is, since we have this fraction here, we want to get rid of the fraction. We can think of this like we're dividing by 3, so we want to do the opposite and multiply by 3. So cross out those 3's and we're left with 98 plus 85 plus x is greater than or equal to, that's a 6, that's a 1. Whoops. 3 times 9 is 27. So we have 276 over there. And then we can go ahead and combine like terms. So 98 plus 85 is going to give us 183 plus x is greater than or equal to 276. Subtract 183 from both sides. And we get x is greater than or equal to 93. So he must get at least, because it's a greater than or equal to, a 93 on his third test. And this is stuff that you guys can actually do when you're trying to figure out your grade at the end of the semester. You just have to kind of figure out how to incorporate the percentages, which if you guys ever have questions about that or what you need to get on a final exam, just let me know. All right, so now final part of inequalities is talking about something called compound inequalities. And we're just going to briefly talk about these because they'll come back in Math 96 if you're taking that class, and potentially 120, I'm not sure, I haven't taught that one. But these are called three-part, or what I usually call compound inequalities. And so compound inequalities, or three-part inequalities, means instead of having two sides to an inequality, we're going to have three. So it'll be something like -3 is less than x is less than 7. So we have two inequality symbols, and they can be different. So let's just say the second one was a less than or equal to. And so if we go ahead and read both parts of this, this is saying in this first part here, if we flip this around and flip this inequality, this is saying x is greater than 3. And the second part here, we don't need to flip. This is saying that x is less than or equal to 7. And so our graph has to satisfy both of those. So I'll put -3 and 7, and I don't usually worry about adding in other numbers. It has to be greater than 3, so to the right of 3, but we can't go past 7 because it has to be less than or equal to 7. So we're still going to use the same rules. We're going to have a bracket at 7 and a parenthesis at -3. So you can always split it up like this if you want to. The way I like to think of this is that x is between, just like it's physically between -3 and 7. On the number line, it's going to be between -3 and 7, and then you just got to figure out parenthesis or bracket. And then interval notation, these ones aren't going to have infinities because the furthest left we go is -3 with a parenthesis, comma, the furthest right we go is 7. And so these ones, some of them are going to look like points on a graph that we'll start seeing soon. So just be careful. Know that this is still the interval notation, and it's not a point or something on a graph. So let's go ahead and just look at an example where we go ahead and solve and graph. Let's go ahead and look at -4 is less than -3 over 2. -3 over 2 x minus 1 is less than 0. And so the goal for these is to get x in the middle alone, and still positive. So first thing we want to do is, just like we solve a regular equation, we want to get rid of this -1 first. So I'm going to add 1, and now we have 3 parts, so we have to do it 3 times. So to the left, the middle, and the right. The left side becomes -3. Still keep the less than -3 over 2x. These cancel, less than 1. And now we want to get rid of this -3/2. So remember, if we have a fraction, we can go ahead and multiply by the reciprocal. So we're going to multiply by, let me see if I can squeeze this in a little better. We want to multiply by -2 over 3. Make sure it's negative because a negative cancels that negative out. And we're going to do that on both sides. And so now this is one to be careful with. Not all of them are going to be like this, but if you have a negative when you're multiplying or dividing, remember we flip our inequalities. Same thing here, except now we have two inequalities to flip. So we need to flip the left and the right inequality. In the middle, we're left with an x. On the right side, 1 times negative 2/3 is just negative 2/3. The left side, that's right, this is negative 3/1. Negative and a negative make a positive, and then these 3's cancel. We're left with 2/1, which is just 2. And so normally, when you're looking at these, this one's a special case because we had to multiply by a negative. If you don't multiply by a negative, you don't have to flip anything. It'll graph just like we did up here. But notice how there's a positive 2 on the left and a negative 2/3 on the right. You want to make sure that you either physically flip it around and rewrite it. So negative 2/3 on the left, x is still in the middle, 2's on the right, but then we have to flip both of these. So you can always do that if you want to, or just know that negative 2/3 is a smaller number and it goes on the left, 2 has to go on the right, and then you always shade in between. And that's a really nice thing about these compound inequalities. So we're going to have parentheses at both. And then our interval notation is going to go from negative 2/3 with a parenthesis up to 2 with another parenthesis. All right, so that's it for chapter 7. Chapter 7, section 2.7, which is also the end of chapter 2. So next time we're going to get into solving some graphing some linear equations, and then a lot of 3.2 is going to be about graphing, and all of chapter 3 really is about graphing and what equations of lines look like.